All right, welcome back, everybody. This is a direct continuation of the previous video. We're going to build on what we've started. So if you haven't seen it, I highly suggest you watch it, because in the last video, we created a little GPS system and started a mining turtle that can strip mine. Today, we're going to do a few things to improve our system here. I think among them, we're going to get into a little more Rednet. We're going to have a computer that the user can use to start the turtle and see status updates from the turtle. We're going to let them dynamically adjust how far they want to strip mine from the computer. And we will also have the turtle complete its strip mine and return to its starting position and offload its items into a chest. So without further ado, let's get started, because we have a lot of coding to do. So in the game, I placed here an advanced computer with an Ender modem on top. I just made a startup script here that simply opens Rednet on the top, because that's where the modem is. So rednet.open will make use of the modem on whichever side you call in the parentheses here. So for this case, it is top, and you see it's active because of the red. Same with the turtle, its right side is open. So we're going to, I guess, get started on the server side of it. This is basically going to be a server. And I'm going to move the UI elements off of the turtle to the server. Okay, so we're going to copy a few things here. Let's copy this. We're going to need that for sure. Let's copy this draw menu, actually. I think this part here as well. Great. All right, so we want the user to be able to dynamically adjust how far they can go. We're going to need to create a new variable for that, and I'm going to call it distance. And by default, I'm just going to set it equal to 20. I think that's a solid number. Now, I have an idea on how we can improve this a little bit more. I think for this, the option name, I want to show what Y level the turtle is going to go to. So to do that, I'm going to concatenate this. Whichever one is selected, I'm going to highlight the Y level. So let's do a, I don't know, in parentheses, Y. Oops, that's an R. Y. And then we're going to concatenate option Y level. If you remember, that is inside this table here. Okay, so Y, option Y level. And then we're going to concatenate that to add the closing parenthesis. So how it should look is we should see like iron. Or we'll see this arrow, iron, and then it'll be like Y16. And that's what it should look like. We'll keep this the same, doesn't have to be adjusted, but we also want to allow them to adjust how far they'll strip mine. So let's print that. Let's print some directions here in this menu so the user knows what to do. I'm going to include a line break here. Distance. This is going to show currently like the default 20. It's going to go 20 blocks. And then we want to enter our control scheme. So W and S was to select your resource. Then we're going to do A and D to change distance. And lastly, we'll just do a press enter to start. So let's see how that looks. There you go. So as you can see, it now displays the Y level that the turtle will go. And we have our distance on the bottom, which is great. So that's a good start. Okay, so now that we have our A and D controls in this little menu here, we need to actually incorporate that into this logic. So I'm going to do a else if key equals keys.a. And then I'm also going to do an else if keys.d. Get both of those down. And for this, we're going to actually adjust our distance variable. Now, I think I'm going to have it increase and decrease by increments of 5. Therefore, I want the absolute minimum to be 5. So we don't want it to go negative. That would be weird. We don't want it to be 0 because that'd be useless. So there's a really nice function in the math library here, math.max. And what this does is you can say an integer, and it means it'll absolutely not go below 5 in this case. So 5 will be our minimum. And then for D, that'll be to increase it. So we'll just add 5 to it. There we go. So let's test that. There you go. It's going up because I'm pressing D. Now we're going to go down. And yeah, it's not going below 5. So perfect. That's what we want. We got that menu here. So we can go ahead and remove this from the turtle. The turtle no longer needs that. And it no longer needs this draw menu here. We're going to keep this options menu because the turtle will need it to reference this. We're going to keep the selected. The selected will be 1 by default. We're going to create some variables, strip length. And by default, I'm going to make it 20. And now we're also going to need another variable for server ID. And I'm going to set it equal to nil. I'm pretty much just creating it. I'm declaring that this exists as a placeholder for now. But the server ID is basically going to be whatever computer the user is using. It's going to be this computer ID right here, 12. It's not going to be hard coded. I think what I'm going to do is have the computer basically broadcast a message out and the turtles will respond and it'll grab that and the turtle will be under its control. We're going to need to go in to the server and have it broadcast that message at the beginning of the program. So immediately I'm going to have it print broadcasting ping to turtles. And then rednet.broadcast. What this does is it basically sends a message to every computer in the game, or at least in range. In this case, with Ender modems, it will be every computer in the game. So local turtle ID and response is going to be equal to rednet.receive. So the rednet.receive command here has well, it actually has more than 2, but it has this turtle ID here is going to correspond to whatever ID the computer is. And then response is going to be whatever contents that message contains. It'll be a string, or it could even be a table. In this case, it's going to be our turtle's ID. So if we don't get a turtle ID, then we're just going to say no turtle responded, which would be very sad. And in fact, we're going to put in a sad face and return. Otherwise, we're going to print connected to turtle ID, and then we'll concatenate turtle ID, and we'll see that number. Now, when we broadcast this inside the turtle script, we need to actually receive it and send an acknowledgement. Now, we'll just go ahead and do it right under here. It's going to be like the first thing this program really does. So we're going to do local, or actually, I'm not even going to put in a function. We're going to do, when the user runs this program, mine, we're going to have it say waiting for start command. Now we're going to do ourselves a loop here, and we need to get a message from the server, get that broadcast. So we're going to do the ID and the message equals rednet.receive. For now, we're going to say if message is ping, then we will rednet.sendID ACK, which is just an acknowledgement saying, yep, we're here. All right, and to double check that this works, I'm just going to print message here. And in the server, I'm just going to also print response down here so that you can actually see these going through. So I'm going to run this first because it's going to wait for the start command. And let's run this. And you'll see down here at the bottom it says ACK. And then here it says ping. So it's going through, it's broadcasting, this turtle is seeing it and responding. So that's great. That is just what we want to see. I'm going to comment these out. now what we want to do is take what we select and send that information to the turtle. So inside this here, I'm just going to, actually we're going to put it right at the end. So local message. And what we need to do is we're going to send a table. We're going to send a message that's saying we're going to start, we're going to send the selected resource, and we're going to also send the length at which it's going to strip mine. So in order to send a table over Rednet, you need to serialize it, you need to condense it. And there is a built-in textutils function called textutils.serialize. And then inside here, put those curly braces. And what we want is we want a type. And we want selected. And we want length. So for type, I'm just going to make this start. Then selected is going to be the selected variable. And length is going to be the distance variable. And that's it. So that we took the message or we're creating a message and we condensed a table into just this variable here. So now we need to actually send it. We're going to send that starting command. And let's rednet.send turtle ID message. Rednet.send, it takes 2 arguments here. It is going to be the computer ID that you want to send it to, as well as a string or a table to send to that computer. All right, let's edit the turtle here. And we need to receive that message and unserialize it. We're going to incorporate it into this loop here. So we'll keep this here, but we're also going to do what I tried to do a moment ago, but I jumped ahead of myself. So we're going to do local data equals textutils, and we're going to unserialize this table. Bring it back into its readable form. So if message equals ping, then we're going to respond with an ACK. We're going to add in an else if, and we're going to say type data. We're going to make sure that it's a table. So we want to be working with the correct message here. And data.type equals start. Then we'll go ahead and give it its info. So selected is data.selected. Or say there's nothing there, we'll just default it to 1. And then we'll do strip length equals data.length or 20. And server ID is going to be equal to ID. And then of course we need to get out of this loop. All right, so I am going to start this turtle here. I'm going to do mine. I'm going to go in this and start the server. Oh, let's see. Line 63. I am missing a comma. Silly me. There we go. So let's say iron, sending start command. Oh, there we go. It's going down. So it's going to mine the iron for 20 blocks because I just kept it at the default. And while it does that, I think we could do with some status messages. So we know where it's at in the process. Because right now we're just sitting here twiddling our thumbs. So in the turtle code, I'm just going to stick this status function right here. I'm going to do a local function, send status. And that's going to be just message. We're going to pass that through. And we're going to make sure that there is a server connected. So if server ID. And then we're going to rednet.send server ID. And we're going to send it a table. So textutils.serialize. And we need to put the table inside. And we're going to send just kind of what it's doing. So status. As well as a message. And that'll make sense in a moment. Just bear with me here. So I think the first status we could send is when it descends here, we want it to let the user know that it reached the bottom or it reached its target. So what we'll do is we don't need this to print on the turtle because that is a little pointless. Instead, we are going to send status. And it's going to be reached y equals, and we're going to concatenate current y. So if you remember, we get the GPS coordinates at the beginning, but we just let the turtle handle its own math here to get its y position. And also, I guess it also does not need to print can't move down here. So we're also going to send that as a status. Now, the reason why we specified type equals status here is because we are looking, let's see, where is it? Where is it? We are specifying the types. So the start and the status will be treated differently. That's how the computer will know what kind of message it is. It's kind of like networking in real life where you have headers, and the headers kind of tells the computer what to expect and how to handle it. That's kind of the same idea I'm doing here, is we're giving it a little header saying, hey, this message is a status, and the message itself is the contents. So I'm just going through, for every print statement, I'm just going to change it to send status, because it no longer needs to be printed on the turtle. It needs to go to the server. So strip mine. We're going to send a status because this is when it's going to start strip mining. All right, so strip mining, we're getting our length and blocks. And then when it's finished, in fact, I'm going to get rid of this and you will see why. So it finished its strip mining. I'm going to just go ahead and, destroy that and bring it back up. We're going to put a chest right here. Anyway, so yeah, it currently functions kind of at the same level we left off in the last video, where it'll strip mine and then return at the beginning of the tunnel. So now we need to send those status updates, and we need to make the turtle return up to the top and deposit its contents into the chest. Okay, so we need to, for one, change strip mine here to be strip length. Otherwise, it's going to do 20 no matter what. And we need to create a couple of new functions here. We're going to do, let's say, right after strip mine function, return to surface. And we're going to pass start y. And we're going to say, we're going to declare a local variable, so local y equals gps.locate. We're going to get the current y level. Otherwise, if we have no y, then we're going to send that as a status. Otherwise, we're going to send a status returning to surface. And we're going to be doing a little while loop. So while y is less than start y, we're going to have it do oh, wait, actually, we need a, just in case, you never know, I'm going to have it detect if there's a block above it. So if turtle.detect up, then we're going to do turtle.dig up. Just to be safe, you never know. If turtle.up, then we're going to do a local, we're going to do a little underscore comma action. New y. Basically, when you do GPS locate, we're getting more than just a y. But I only want to get the y. I'm just kind of, this just is a placeholder. So new y equals gps.locate 2. And we're going to do the same thing. We're going to make sure that we have GPS signal here. So if new y, then we're going to say y equals new y. Actually, I don't know why, but this makes it confusing to me. So I'm going to make this one, oh shit. I'm going to make this one line. There we go. That looks better in my opinion. All right, now I want an else here. So if turtle is not able to move up, we're going to send a status blocked while returning up. And we'll just do a little sleep. And at the end of that, it's going to check if there's something above it and break it. And then it's going to move up. If it is able to move, it's going to get its new GPS coordinates, because at the end of the day, we are only running this while y is less than start y. So once y equals start y, then we are done. We're just going to go ahead and send status saying returned to starting y. And we're going to concatenate y. Okay, so this should bring us back to its starting position. Now we need a little function here to deposit all our items into a chest. So let's just call it deposit items. Pretty straightforward. We're going to send a status depositing goods. And we're going to have the turtle, well, actually it should already be facing the chest. So right then and there, we should just be able to have it drop everything. Now, turtle inventories have 16 slots. As you can see, it's a 4x4 grid. So we want it to cycle through all of its slots and put it in the chest. To do this, I'm going to do a for loop. So for slot equals 1, 16 do, meaning we're going to start at slot 1 and end at 16. We're going to do turtle.select and then a slot. So turtle.select 1, and then turtle.drop. Now, if you do turtle.drop in front of a container, it's going to put the item inside the container, in this case, a chest. I'm pretty sure the same thing applies to some like hoppers and droppers. And then we'll go ahead and select slot 1 again, because at this point when it's finished, this slot 16 on the bottom right will be highlighted. And I just like to return it back to its original state by selecting slot 1 again. So once we select that, we're going to send a status again saying items deposited. And we're going to do a little happy face, because that is very good news. And at this point, I'm going to have the turtle turn all the way around. And it should be essentially exactly where it started. It will be facing this way again, items in the chest, hole dug out. Now we need to add these new functions here. We're going to get rid of these print statements because those are not needed. Actually, we don't need this because we already have the selected resource. So target Y, we're going to change this. So local target Y equals options selected dot Y level. Descend to target Y, strip mine, strip length. Now we need to return to surface, start Y, and deposit items. So that should be it for the turtle. Now for the server side, we need to receive these updates that we're sending from the turtle. So where should we put these? I guess right here, we'll just, I guess have a while loop. And we're going to say local ID message equals rednet.receive. So we're looking for computers, sending messages here. If ID equals turtle ID, basically we want to make sure that it's only the turtle we are working with and not some other computer trying to mess with us. We are going to unserialize this data, because if you remember, we sent it as a table with 2 entries in it. So local data equals textutils.unserialize, and it's going to be message. Now we need to make sure that this type, so if type data, we got to make sure it's a table, so it's not something weird that's going to cause errors when we try to read it. And we're going to make sure that the type of data inside, if you remember, where is it? Right here. So type is status. So we're going to make sure that this is status. We're just gonna do, all right, I'm going to do y level 15. And we're gonna print out our status here. And it's gonna be data.message or nothing. And that should be it. So we should delete whatever is there before and print whatever status we receive. And that looks good to me. Just gonna check these over real fast. Okay, I also want to rework this here. So instead of what we have going on, I'm actually gonna make this a function. So we're gonna say local function get y. Put an end in here. We're going to get rid of this. We're going to keep this for loop. And I don't really care what the x position is, and I don't care what the y is. So we're going to do a underscore y. GPS.locate. It's going to try for 2 seconds, and it's going to do it 5 times. Make sure that the y we get something. So if y, then return y and end. We can just go ahead and get rid of this. All right. We will get rid of that. Keep the sleep there. There we go. Indent it correctly. Basically, we're going to put in the return nil so that if we do get through 5 attempts and get nothing, then we can just return nil and go from there. And now what I'll do is I'm going to get that start y. So local start y equals get y. We're going to actually run that function with this command. And then we'll have this do its thing. That should be it. Okay, so let's test this out. Ooh, line 79. What did I put? Oh, there's just a W in there. We do not need that. All right. Mine. Waiting for start. Okay, good. Let's go ahead and run this again. Now, this time, I'm just going to have it go for 10 blocks. We're going to dig for iron. Sending start command. It's going down. So it should give us a status update when it reaches Y level 16. There we go. So it reached the bottom. It's now strip mining 10 blocks. Which, you know what? That kind of... I realize it's a little redundant. It doesn't even matter if it gives us a status update for when it reached this, because it's just completely overwritten by the other one. So we can just remove that. Actually, I'm just going to comment it out. It's done, so it's returning to surface. All right, so I realized the turtle did do its thing and went down, but it came up at the end here and dropped all the items on this tree. So not ideal. Reason why is because in the code, it doesn't turn around. So let's go ahead and do have it turn around. Okay, let's try this again. Okay, we got our update. It is strip mining the 10 blocks. All right, so it is done with that. Turned around, it's coming back up. Yep, returning to surface. All right, here he comes. All right, he's dropping the items into the chest. Selected slot 1 and turned back around. So it did its thing. It mined its 10 blocks, came back up, dropped the items off in the chest, and turned back around. Exactly how it started. So that's actually going to be the end of this video. That accomplishes what we wanted. We're making more use of the GPS by getting the Y level down at the bottom here. Not that we really had to, but I think over the course of this project, I'm going to have it utilize the GPS more, because eventually we're going to have it live track its current position, X, Y, and Z levels. Beyond that, it is definitely coming along. I hope this was helpful to you, and I'll see you next time. All right, bye-bye.